Class 7, Chapter 13, Motion and Time. In Class 6, you learn about different types of motion. You learn that a motion could be along a straight line, it could be circular or periodic. Can you recall these three types of motions? In Table 13.1, give some common example of the motion. Identify the type of motion in each case. So, the soldier in a march past, a straight line. Block cart moving on a straight road, straight line. Hands of an athlete in a race, it's periodic. So these are the all example of whether the motion are straight line, circular or periodic. It is common experience that the motion of some object is slow while that of some other is a fast. So what is slow and fast? We know that some vehicles move faster than others. Even the same vehicle may move faster or slow at a different times. Make a list of 10 objects moving along a straight path. Group the motion of these objects as a slow and fast. How did you notice which object is moving slow and which one is moving fast? If vehicles are moving on a road in the same direction, we can easily tell which one of them is moving faster than the others. In activity 13.1, there's a picture given of 13.1 and 2 to compare that the the vehicles on the road after a period of time, which is a 5 minutes, and then you have to find out which vehicle is moving faster. So if you look at carefully, you see the place, the displacement or the movement of the green car makes it more faster than the other. We often say that the faster vehicle has a higher speed. In a 100-meter race, it is easy to decide whose speed is the highest. One who takes the shortest time to cover the distance of 100 meters has the highest speed. Now, what is the speed? You are probably familiar with the word speed. In the example given above, a higher speed seems to indicate that a given distance has been covered in a shorter time, or a large distance covered in a given time. The most convenient way to find out which of the two or more object is moving faster is to compare the distance moved by them in a unit time. Thus, if we know the distance covered by two buses in a 1 hour, we can tell which one is slower. We call the distance covered by an object in a unit time as the speed of the object. When we say that a car is moving with a speed of 50 kilometers per hour, it implies that it will cover a distance of 50 kilometers in 1 hour. However, a car seldom moves with a constant speed for 1 hour. In fact, it starts moving slowly and then picks up speed. So when we say that the car has a speed of 50 kilometers per hour, we usually consider only the total distance covered by it in a 1 hour. We do not bother whether the car has been moving with the constant speed or not during that hour. The speed calculated here is actually the average speed of the car. In this book, we shall use them term speed for average speed. So for us, the speed is the total distance covered by divided by the total time taken. Thus, speed is equal to total time, total distance covered divided by total time taken. Now, in everyday life, we seldom find object moving with the constant speed over a long distance or for a long duration of time. If the speed of an object moves moving along a straight line keeps the changing, its motion is said to be non-uniform. On the other hand, if an object is moving along a straight line with a constant speed, is said to be uniform motion. In this case, the average speed is the same as the actual speed. We can determine the speed of given object once we can measure the time taken by it to cover a certain distance. In class 6, you learn how to measure a distance. But how do we measure time? Let's find it out. Measurement of time. If you did not have a clock, how would you decide what time of the day it is? Have you ever wondered how our elders could tell the approximate time of a day by just looking at a shadow? How do we measure time interval of a month, a year? Our ancestors noticed that many events in a nature repeat themselves after a definite time interval of time. For example, they found that the sun rises every day in the morning. The time between one sunrise and the next was called a day. Similarly, a month was measured from one new moon to the next. A year was fixed as the time taken by the earth to complete one revolution of the sun. Often, we need to measure intervals of time which are much shorter than a day. Clocks or watches are perhaps the most common time measuring device. Have you ever wondered how clocks and watches measure time? The working of clocks is rather complex, but all of them make use of some periodic motion. One of the most well known periodic motion is that of simple pendulum. So, the wall clock has the pendulum in it, and we have seen that it shows the periodic motion. A simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. The metallic ball is called the bob of the pendulum. It shows that the pendulum at the rest in its mean position. When bob of the pendulum is released after taking it slightly to one side, it begins to move to and from. The to and fro motion of a simple pendulum is example of periodic or an oscillatory motion. The pendulum is said to have a complete one oscillation when its bob starting from its mean position O moves to A to B and back to O. The pendulum also completes one oscillation when its bob moves from one extreme position and to the other extreme position B and come back to A. The time taken by the pendulum to complete one oscillation is called its time period. In activity 13.2, it shows that set up a simple pendulum as shown in the figure with a thread of a string or a length nearly 1 meter. Switch off any fans nearby and let the bob of the front pendulum come to the rest at its mean positions. After the mean position of the bob on the floor below it or on the wall behind it, to measure the time period of the pendulum, we will need a stopwatch. However, if a stopwatch is not available, a table clock or a wristwatch can be used. To set the pendulum in motion, gently hold the bob and move it slightly to one side. Make sure that the string attached to the bob is taut while you displace it. Now release the bob from its displaced position. Remember that the bob is not to be pushed when it is released. Note that the time on this clock when the bob is at the mean position instead of the mean position, you may note that time when the bob is at a 1 its extreme positions. Measure the time the pendulum takes to complete the 20 oscillations. Record your observation. In table point 13.2, the first observation shows is just a sample. Your observation could be different from this. Repeat these activities a few times and record your observation. By dividing the time taken for 20 oscillations by 20 gets the time taken for one oscillation or the time period of the pendulum. Is the time period of your pendulum nearly the same in all cases? Note that the slight change in the initial displacement does not affect the time period of your problem of pendulum. Nowadays, most clocks or watches have an electric circuit with one or more cells. That clocks are called quartz clock. The time measured by the quartz clock is much more accurate than that by clocks available earlier. Unit of time and SPD. The basic unit of time is a second. Its symbol is as. Larger unit of time is minutes and hours. You already know how these units are related to one another. What would be the basic unit of speed? Since the speed is a distance by time, The basic unit of speed is a meter per second. Of course, it could also be expressed in other units such as a meter per minute, kilometer per hour. You must remember that the symbol of all units are written in a singular. For example, we write 50 kilometer, not 50 kilometers, or 80 centimeter, not 80 centimeters. Pujo is wondering how many seconds there are in the day and how many hours in a year. Can you help him? Different units of a time are used depending on the need. For example, it is convenient to express your age in a years rather than in a days or hours. Similarly, it will not be wise to express in years the time taken by you to cover the distance between your home and your school. How small or large is the time interval of 1 second? The time taken is saying aloud 2001 in is nearly 1 second. Verified by counting aloud from 2001 to 2010. The pulses of normal healthy adult at rest beats about 72 times in a minute, that is about 12 times in a 10 second. This rate may be slightly higher for a children. Many times measuring devices were used in different parts of the world before the pendulum clocks became popular. Sundials, water clocks, and sun clocks are some examples of such devices. Different designs of this device were developed in different parts of the world. Measuring speed. Having learned how to measure time and distance, you can calculate the speed of an object. Let us find the speed of a ball moving along the ground. 13.3. Draw a straight line in one ground with a chalk powder or a lime and ask one of your friends to stand 1 or 2 meters away from it. Let your friend gently roll a ball along the ground in a direction perpendicular to the line. Note that the time at the moment the ball crosses the line and also it comes to the rest. So now measure the time. Does it take to come to the rest? Measure the distance between the point at which the ball crosses at the line and the point where it comes to the race. You can use a scale or a measuring tape. Let different groups of repeat this activity. Record the measurement in a table 13.3. In each case, calculate the speed of the ball. You may now like to compare your speed of walking or cycling with that of your friends. You need to know the distance of school from your home or from some other point. Each one of you can then measure the time taken to cover the distance and calculate your speed. It may be interesting to know who among you is the fastest. Speed of some living organisms are given in table 13.3. You can collect the data and you can write it down here. Rocket launching satellites into Earth orbit often attains a speed up to 8 km per second. On the other hand, the tortoise can move only with a speed of about 8 centimeters per second. Can you calculate how fast is the rocket compared to the tortoise? Once you know the speed of an object, you can find out the distance moved by it and given time. All you have to do is simply multiply the speed by time. Thus, the formula is for this: distance covered by is equal to speed into time. You can also find the time an object would take cover a distance while moving with a given speed. You might have seen a meter fitted on the top of the scooter and motorcycle. Similarly, meters can be seen on the dashboard of the cars, buses, and other vehicles. That is shown in figure 13.7. Shows the dashboard of the car. Note that one of the meter has known a kilometer per hour written on at the corner, and this is called a speedometer. It records the speed of directly in kilometer per hour. There is also another meter that measures the distance covered by the vehicles, and this meter is known as odometer. While going for a school picnic, Pally decided to note down reading on the odometer of a bus after every 30 minutes. Till the end of the journey and later of the school, she recorded her readings in the table 13.5. Can you tell how far the picnic spot from the school? And can you calculate the speed of the bus looking at the table? Would you tease Pally whether she can tell how far they would have traveled till 9:45? Pally had no answer to this question. They went to their teacher and she told them that the one way to solve this problem is to plot a distance time graph. Let us find out how such graph is plotted. So distance time graph is a way of describing the data in a graphical format. So you might have seen that newspaper, magazine, etc. present information in a various form of the graph. To make it interesting, the type of graph shown in figure 13.8 is to know that as the bar graph. Another type of graphical representation is a pie chart, and the graph shown in figure 13.8 is example of the line graph. The distance time graph is a line graph. Let us learn to make such a graph. Take a sheet of paper, graph paper, and draw two lines perpendicular to each other. It as on figure 13.11. Mark the horizontal line with X or X. It is known as the x-axis, or similar mark on the vertical y or y dash. It is called y-axis. The points of interest intersecting of x or x and y or y dash is known as the origin. The two quantities between which the graph is drawn are shown along with the two axes. We show the positive values on the x-axis and along OX. Similarly, positive value of on a y-axis along with the OY. In this chapter, we shall consider only the positive values of quantities. Therefore, we shall use only the shaded part of the graph shown in figure 13.11. Bujo and Paheli found out the distance traveled by the car and the time taken by its cover that distance. The data is shown in table. Now you can make the graph by following the step given below. So you can draw perpendicular lines to represent the two axes, then decide the quantity to shown in the figure, x-axis and y-axis. Then choose a scale to represent the distance, like 1 minute is equal to 1 centimeter, 1 kilometer is equal to 1 centimeter. Mark the value on the time and the distance on the respective axis. And now you have option, you can point the graph and create a line segment through it. So that's how you can prepare the graph like this. Generally, the choice of scale is not as simple as it is example given above. We may have to choose two different scales to represent our desired quantity on the x and y axis. Let us try to understand this process with an example. Let us again consider the motion of the bus that took Paheli and her friends to the picnic. The distance covered and the time taken by the bus are shown in the table 13.5. The total distance covered by the bus is 80 kilometers. If we decide to choose a 1 kilometer is equal to 1 centimeter, and we shall have to draw the axis of length 80 centimeters, this is not possible on the sheet of a paper. So on the other hand, a scale of 10 kilometers equal to 1 centimeter would require as an axis of the length is 8 centimeter. This scale is quite convenient. However, the graph may cover only a small part of the graph paper. Some of the point to be kept in mind while choosing the most suitable scale for the drawing graph. First, the difference between the highest and the lowest value of each quantity. Second, intermediate values of each quantity so that with the scale chosen it is convenient to mark the value on the graph. Third, to utilize the maximum part of the paper on which the graph is to be drawn. Suppose that if we have the graph paper of size 25 to 25 centimeter, 25 by 25 centimeter, one of the scale which meets the above conditions and can accommodate the data of table 13.5 could be distance 5 km by 1 centimeter and time 6 minutes is equal to 1 centimeter. Can you draw the distance time graph from the motion of the bus? Is there a graph drawn by you similar to the one which is there in the figure? Distance time graph provide a variety of information about the motion. When compared to the data presented by the table, for example 13.5 gives you information about the distance moved by the bus only at some different night time intervals. On the other hand, from the distance time graph, we can find the distance moved by the bus at any instant of time. Suppose we want to know how much distance the bus had traveled at 8:15. We mark the point corresponding to the time 8:15 on the x-axis. Suppose this point is A. Next, we draw a line perpendicular to the x-axis at point A. We may then mark the point T on the graph at which this perpendicular line intersect. The next draw a line through the point T parallel to the x-axis, and this intersect at the y-axis at point B. The distance corresponding to the B point B On the y-axis, OB gives you us the distance in the covered by bus at 8:15 a.m. How much is the distance in kilometers? Can you now help Hailey to find it out the distance moved by the bus at 9:45 a.m.? Can you also find the speed of the bus from its distance time graph? So try this all. Thank you very much.